Today I'm going to talk about LeetCode question number 19, remove nth node from end of list. So given the head of a linked list, remove the nth node from the end of the list and return its head. So for example, we have this list here, and we want to return or remove the second to last element in the list. Obviously this is a second to last element, so we remove that and return this list here, where this is the head. Okay. And yes, similarly, I guess here we only have one node in this linked list, and we want to remove the first node from the end, which is, I guess, this one. It's the only one. So return null, and this example here. So 1, 2. Remove the first node from the end, which is obviously this one. So all we return is this guy here. Okay. So how do we go about this? So one easy way is to traverse through the list, count how many nodes there are, and then subtract n from how many total nodes there are. So for example, we have 5 here, so 5 minus 2 equals 3. So what we do is we keep 3 nodes, and then we'll counter, or how should I say this? So we want to remove the second to last node. Okay. Okay, so what we do is we have 3 here, so we go 1, 2, 3. And yeah, basically here we do 3 jumps, and then we're here, we're at the node that we want to remove, so then we would, I guess, remove that. Okay. So that's simple enough. Similarly here, if we have like 1, 2, and we want to remove first node, so we count how many there are, 2, so 2 minus 1 equals 1, so we jump 1, and we're at the node that we want to remove. Okay, so it sounds simple enough, but this does require 2, and it is O of n time, but this requires 2 iterations, so it's like kind of O of 2 of n, but we always exclude the constant expression. How can we get this in just O of 1n notation? By that I mean just traversing through the list only once. Okay, not twice. So what we can do is have 2 pointers, let's call it P1, P2, and have the second pointer here be n steps ahead of the first pointer, okay? So that P2 becomes 1 over n steps, n steps ahead of P1, okay? So that way, P1 is behind P2 by a factor of 1 over n, okay? So let me show you what I mean here using an example. So we have P1 and P2. Okay, they're initially both here. So first we want to put P2, traverse P2 n times, okay? So 1, 2. Oops. Now P2 is here, okay? It's n jumps ahead of P1, okay? P1 is n jumps behind. So now what we want to do is now for both pointers traverse them forward, okay? And then when we stop, when P2 becomes none, okay? So let's do that. So this jumps 1, this jumps 1, okay? So now this becomes P1, or sorry, this becomes P2, this becomes P1. Okay, now jump 1 again, P2, P1, now jump 1 again, P2, P1. Okay, now notice how P1 is right at the node that we want to eliminate. Okay, so that's how we want to go about it. Another thing you may be asking is, how do we eliminate a node we're already at? Well, simply put, we want to keep like a previous tracker that will stay like one space behind P1. So previous tracker will be here, and then what we'll do is just go like that. Okay, so P1 will be at the node we want to eliminate. Previous will be at the node behind the node we want to eliminate. So we will simply update this node's next pointer. Okay, and yeah, that's how we'll go about it. So I'll show you another example. So 1, 2, 3. What if we wanted to remove the third node from the end? So P1, P2, we move P2 ahead 3 times. So 1, 2, 3. Now P2 is here. Okay. And now, since P2 is already none, we don't have to move P1. We're already at the node we want to eliminate. Okay. So in that case, what we want to return is this head. Okay. I'll show you one more example here. So for 1, 2, 3, 4, 5, 6, 7, and we want to return 4th from the end. So 1, 2, 1, 2. So you want to remove this guy. So again, P1, P2, and previous will just be lagging behind P1 just by 1 space. So we'll want to 4th from n, or actually it's easier to say n equals 4. Okay, so we want to progress P2 4 times. 1, 2, 3, 4. Now P2 is here. Okay, and now we want to traverse both P1 and P2 and previous at the same time until P2 becomes none. So I'll just fast forward that. So 1, 2, 3. So P2 will be here, and then this will be 1, 2, 3. P1 will be here, while previous is going to be here. So P1 is at the node we want to eliminate, and then previous, we're at the previous node of the node we want to eliminate, so we simply update this pointer here to point at P1.next, and that's how we're going to go about it. This is O of n runtime, O of 1 space, and this only takes 1 traversal through the linked list. Okay, so now to code it out, what I'm first going to do here, initialize my pointers. So with my previous pointer, that's going to lag behind P1. So P1 is going to be head, and P2 is also going to be head. So I'm going to iterate make P2 jump n steps ahead of P1. So for I in range 0 n, P2 is equal to P2 dot next. Okay, and first off, what I want to check here is if P2 equals none. So does that mean, this basically means when P2 is none, then n is the entire length of the list. So here we have 5, 1, 2, 3, 4, 5. So that means we want to remove the 5th last element from the list, which turns out to be 1. And P1 is already at 1 here, so what I want to do is return P1 dot next. Okay. Else, what I want to do is, while P2 does not equal none, previous equals P1, P1 equals P1 dot next, and p2 equals p2 dot next. Okay, and once that's done, what I want to do is, so now p1 will be at the node that the nth last node from the end that we want to remove. So what we want to do now is previous dot next is equal to p1 dot next. Okay, so we're gonna jump over that. Okay, and finally return head. Okay, so I'll try compiling it. Okay, great. I'll try other examples. Okay, and I'll submit it. Okay, great. Thanks for watching.